Okay, so and then hopefully more will come anyway. That's cool too. Oh, this is great. Okay, I think we are off to the races. Hi, everybody. How are y'all doing today? And this is such an awkward format, I can't expect an honest answer, but I'm going to ask it anyway. And I think Jonathan is helping organize this thing. Do I need to pay attention to these notifications, Jonathan, about who enters, or are you going to take care of that?
Yeah, I'll be taking care of that.
I really appreciate that. All right. Excellent. Well, let's just go ahead and get started here. And everything will make sense in due course. Let me share my screen first and foremost. And okay. Oh, that's the wrong one because you're seeing the presenter view, right? Okay. All right. Hold on. Try this one more time. 2. Okay. Now you're seeing the full slide, correct?
Yes.
Okay. Wonderful. All right. Well, thank you everybody for coming. This is really a tremendous opportunity, and we'll get to know each other. We'll learn a lot about NLP, and gosh, there's a lot more to say. So this is an introduction to natural language processing. And I have some slides for you to start. You're about to meet me, and we'll talk about our agenda. But first things first, if you can go ahead and copy down this first link here, bit.ly/NLP Python 2020, and put it into your browser. What that's going to do is not skip a slide. It's going to open up a binder. So I'll show you what that looks like. I'll give you a minute just to copy that down, put it in your web browser of choice. Doesn't matter what it is. Okay, so this is what it looks like for me. I can just click the link, it's on my screen, and this is what comes up for me. It's this little web page. It's actually, what this is doing is creating a Jupyter notebook, so we can all be in the same exact environment. It gets rid of a lot of installation issues and things like that, but sometimes it takes some time to start. So it's starting. You should be here, and I'll do one more thing for you. I'm gonna see if I can, hold on just a second. I'm gonna put the link in the Slack or the Zoom. There we go, there's that. And the chat, there's the chat. There we go. Okay, so you should see in the chat the link that I just shared with you, and I'm gonna start this presentation again. Okay. The second link here, you don't need to worry about. It goes to the repository. I'm going to give it to you again at the end. Yes, hopefully it's in the email you got anyway. Right on. So I'm Jaren Haber. Let me introduce myself. Or you know what? Getting ahead of myself. We've got introductions first, and then I'm going to walk you through the basics of NLP, including the research design, some common applications and tools. We'll take a short break because who wants to stare at a screen for 2 straight hours? And then we're going to go through a notebook together for the remainder of our time, about 50 minutes or so. And tomorrow looks similar, except there's no presentation. It's just straight notebook working together on some applications of dictionary methods. Okay, so I'm Jaren Haber. I'm a postdoctoral fellow at Georgetown University with the Massive Data Institute. I find natural language processing to be one of the best applications for social science sort of studies, because there's like so many different opportunities for using digitized text. My research is focused on charter schools and organizational theory, and increasingly about politics, and especially the current election and COVID misinformation. There's a couple of things that I've sort of worked on, but I just got my PhD from UC Berkeley. In the Department of Sociology, worked with Heather Haberman, Rob Willer briefly, and others like Neil Flickstein, you might have heard of. Yeah, so immediate cases. Oh yeah, and I use Python. I'm a beginner with R. With Python, I'm pretty good, maybe intermediate advanced. although CS people use it so much differently than I do. So I want to hear about each of your own background, and it's a little difficult to do with a larger group like this. So what I'm going to do is put you all into breakout rooms super randomly with 3 other people or so. And I'm going to ask each of you to learn these things about your neighbors: their name, where they come from, any project they're using with NLP, and how good they are with Python, like to start. Did they just learn it? Are they seasoned and maybe had other kinds of experiences with it? Yeah, so learn that about each other, and we'll come back and I might just popcorn style hear from a few of you. Again, just name, affiliation, projects, and Python skill. Please go ahead and join up in your breakout rooms.
Okay.
Hi, Jaren. I ended up in the room by myself, so I came back out.
Okay, let's put you in room 8.
Okay.
Okay, I think most people are back. Is that right? Yeah, it looks like we're all closed. Give me a thumbs up if you're back and you can hear me.
We're back.
Okay, that's great. All right, so just so everybody is aware of this, I'm going to be asking you time and again to give me your input on whether you're caught up to speed, have any questions. So be sure to find the participants tab in your Zoom, and there's little buttons in there, including yes, no. You should be able to raise your hand. So if you're not sure how to do any of that, please send a message out and someone will help you. Okay, but let's, it looks like those rooms were smaller than I anticipated because not everyone is joined quite yet. I hope you had a chance to meet someone, learn something new. And yeah, this is meant to be a pretty broad-based, inclusive group of people that just want to get started with a new tool. So let's get started together. And before I go, let me just, before we move on, let me just acknowledge the support of MDI and Jonathan Beam especially for helping make this possible, sending out lots of emails, getting people together, making sure the Evite works. Great. So if it weren't for that, we couldn't do this. Thanks again to them. All right. What are some of our goals here for this workshop? Broadly, we're learning how to think about using text as data. So much of our world is online now, and even if it's not online actively and you can go and find it very freely, it's been digitized and is stored somewhere, and you might need special access. So there's tons of opportunities for using text as data and learning about how people interact and the world that we've constructed together, whether it's from literature to politics, to even looking at code people have written. So at a high level, what we're talking about is a few primary CTA methods. Okay, so natural language processing, computational text analysis. I might get those mixed up sometimes. They're pretty much the same. We're going to talk about what kinds of questions these sorts of methods could answer, talk through the steps of designing and implementing a project using these tools. And so besides that sort of general understanding, we're going to do some very hands-on practice with preprocessing text data. That's the introductory, well, it is introductory, but it's also something everyone has to do. It's like the fraternity hazing. To get in, you have to learn how to do this. It's not always fun. I almost always get headaches trying to figure this out, which is why you need to learn how to do this, and I'm going to help you. The other thing we're practicing is dictionary methods, another very basic NLP approach, which we'll talk about, and some like not bare bones, like foundational packages for you to learn. And we're going to practice our NLTK as a natural language toolkit and scikit-learn. And then I'm going to give you a lot of other resources to learn. But today and tomorrow is going to be a really good start. So give you some scripts you can come back to, as well as a lot of references you can keep working with. All right, so what is NLP used for? A lot of different things. One of them is machine translation. You can type in pretty much any quote from any language into Google, for instance, and it'll translate it for you. Here's a famous literary passage, I think from Dante's Inferno, but I'm probably wrong. Oh no, it's, I'm forgetting the name. Somebody knows. Yes, but yeah, what's happening under the hood here, there's actually a lot of pretty cool NLP techniques happening, which people at Google, Amazon, a lot of other luminaries in the field have incorporated and brought to your fingertips. So if you want to learn what's happening behind the scenes Google here, stay with me. Okay, another thing that's common is machine recognition. And I'd love your input. If you have a smart speaker, please give a yes in the participants window. I just want to get a sense from people. Okay, I see. All right. So maybe half a dozen so far. I'm surprised every time I answer this question because I think that everybody has one, and yet I ask a room full of people and it's like one in 10, maybe 1 in 5 in this room. Try asking your smart speaker if you have an Alexa, do you believe in ghosts, and see what she says. I'm told it's funny. I don't have one, so I can't check that. But yes, this is built on NLP. It actually has to parse your speech. So it takes in an audio signal and turns that into turns that into text, which then there's an NLP pipeline to work with. So even in something like this, the tools we're talking about are foundational. Another thing it's used for is question answering. And there's iteratively, like time and again, some of the big conferences, NLP and CS people, computer science people are trying to develop algorithms to answer a question the most intuitively. And there's a lot of different tools based on this, and some of them are incredible. But even if you just use Google and you type in something like, when is election day 2020? Google's pretty smart. Like they rank sources by authenticity increasingly. So they don't just give you a bunch of junk or conspiracy theories that a lot of people are reading. They're like, oh, we should actually use a reputable source. But that's like sort of a hand-cranked version. If you scroll down, there's even their ranking algorithm is happening, and they're learning to parse the parts of speech in your question and give it an answer that's the most useful. So there's that's one other very common application of it. And some software libraries you're going to see over and over again, and we will include SciPy, scikit-learn, NLTK. We won't use the machine learning stuff for this. This is not that high level just yet. But Keras and TensorFlow are really excellent for that. Spatie is state of the art for a lot of these applications, but it's a little harder to use. So we're not going to get there this time. We are going to use some NumPy. Yeah, so NLP is an increasingly heterogeneous and populated endeavor. You're going to find a bunch of stuff online in Stack Overflow, but these are some of the main domains of interest. Artificial intelligence, people trying to, I mean, the idea of a neural network is arguably artificial intelligence. I think people would say that's true, but it's not approaching a human level cognition. That's not what we're after, but they are very good at doing things like question answering and quickly processing information in a sort of deep learning network for a lot of different applications. Another one is machine learning. And these are kinds of names of domains. Machine learning uses a lot of statistical models. Like some people, depending on who you ask, would say that even what's under the hood in terms of maximum likelihood estimation is a form of machine learning. But yes, there's a lot of that happening in NLP. Representation of language, we'll talk about how some of that works. And then the other domain is kind of loosely speaking, social sciences and humanities. I come from sociology. Y'all probably have a lot of other different backgrounds. And yeah, look at how language has a social context, how it communicates that context in kind of culturally nuanced ways. And often will reproduce social stratification, those kinds of things. So it's just a general sense of what who you're going to be talking to, even probably in this workshop. Just a couple examples for you. A pretty amazing recent social science application, computational social science, was painting the network of Twitter users based on who they're following and who they're citing or retweeting, which is something that's embedded in the text as well as in the networks. And yeah, if you look at party identification, there's pretty clear regional or political polarization happening on Twitter. Another example is what New York Times is increasingly doing, putting out these maps. They're processing a lot of text from local news and a lot of other places to track COVID cases is one thing. They've also tracked who's affected by insurance changes with the Affordable Care Act. There's a lot of this happening, and some of the visualizations are really cool. NLP is one of their main things that they use. And then computational humanities, here's just one example that we'll kind of look at the fraction of books written by women versus men since in the last couple hundred years. And yeah, it's been changing, but there's still mostly being written in fiction. We will look at that more. Okay, so as far as what kinds of data sources you might have, text as data, there's so many different kinds. Newspapers, even interviews, people transcribe these and they're sometimes in publicly available data sets or the ones that you've collected. People often digitize their field notes. So like for any given project, there's probably some rich text that you could even analyze. Throw a topic model at it or whatever. There's going to be a lot of things you're going to learn how to do. Diaries and memoranda, social media is something that's huge, as well as political speeches. Should update that photo. But the idea is there's so many different aspects of our current world that are represented in digital text. Okay, and it's important to distinguish between natural language, so things that have a lot of ambiguity and nuance in it, such as time flies like an arrow, fruit flies like a banana. Try to wrap your head around that one. Yeah, I won't say any more. I think the multiple meanings kind of speak for themselves. Compare that to something that's an artificial language and developed intentionally for purposes of clarity. So statistical models like this, we've got all these different covariates, both an error term and even code. People have done impressive work just trying to understand how, what are the social significance underlying how people use code. So things like coding race as a binary, for instance, white or other, versus having different categories. These are things that have pretty nuanced social connotations. And yeah, so different domains of language, whole different approach. As far as our sort of natural approach to analyzing text, take a look at this. As president, I can't be locked in a room someplace for the next year and just stay and do nothing. And every time I go into a crowd, I was with the parents of our fallen heroes, and they come up to me and they would hug me. I'm not going to not let them do it, to be honest with you. And that was Trump like 3 days ago, maybe it was 4, something like that, and his digitized town hall or public hearing town hall. So to understand this, most of the time we would need to read through this as humans. And you can see just even from this quote, the different kinds of meanings that are at play with each other. Like I could go through this and code, who he's signaling to and what kinds of issues he's like kind of taking a stance on implicitly, just from the language. A computer can't do that without a much broader set of information. So how can we get something like close reading with computers? That's one way to think about it. Another way to think about it is doing something called distant reading. So getting a computer to give us maybe not as nuanced an understanding as we have, but something much more scalable, much faster, more reproducible, and without as many of the, or I guess with different biases than humans bring into the fore when they're reading something. There are other biases. There's a lot of good research coming out on this. Consider reading or listening to Algorithms of Oppression, fascinating read. And also distant reading is usually more consistent. So if you set up the right precautions, you can have a much more reproducible and I think probably fair application. Because if you just have a couple of people read a bunch of text and code them by hand, that's not really reproducible. A different group of people will get very different codes. By having a computer do it, we can do this more consistently and fairly. Okay, so our model for of text we often work with in NLP, we start with a corpus of documents. Document is a kind of broad term, could be a tweet, could be a speech, could be a website, could be a journal article, lots of different representations, varying length, complexity, and also domain-specific language. The objective here is really to map some aspect of the raw text, okay, the text itself, onto some attribute VI, which is often an output. And then our estimation here for that output, for that attribute, can be used for descriptive or causal analysis. So let me clarify that with a couple examples. Movie revenues. We can take in something like the text of a movie review, IMDb, Rotten Tomatoes, whatever. And those are often very colorful and useful. And some are written by professionals and some by others, you or me. And based on that, try to predict their box office revenue. You'd be surprised what you could learn. Just if you look at the sorts of language, even just the sentiment of a bunch of movie reviews for some film, often there's really thousands of these, and map it onto their success. Another thing you could do is take in tweets people use and try to geolocate them based on the language and the terms. What do you call this? Much like people have accents, there's kind of this like subcultural specific language. And one of my favorites for this is pop versus soda. And there's a little map there. You can see that California, where I grew up, we call it soda. These other things don't make sense to me. I'm still trying to find compassion for people who refer to cola as pop. But apparently they do in much of the Midwest and Northern United States, whereas for Coke, they call it that and refer to the same thing, even if you're talking about Sprite, I guess, in the southern part of the US. So you can get this kind of information just from tweets. And I'm going to do one more and then look to see if I have a couple questions in the chat. And then another great one is on Reddit. There's what do you call it? I guess there's a subreddit where people ask for pizza in some kind of creative as you can be, try to convince people to send you a pizza. So what you take in is the text of the Reddit request, and the response is got a pizza or didn't. I just think that's really amusing. Yeah, okay, so there you go. You take in the raw text, map it onto some attribute, use that for descriptive or causal analysis. One more example. If you look at the fraction of words about female characters written by women over time, it's from a recent digital humanities study by Ted Underwood and David Bamid and Zabrili. You see it's been pretty consistent for written by women, if it's about women. For men, it's just the absolute level is much lower and it's been tightening. The difference is more clear. Whereas I think in the early 1800s, you had less data probably. Here you're seeing that the difference is consistent. Okay, so we're going to jump on to NLP research design, but I think I see a bunch of things in the chat. So let me see if I need to respond to anything. Okay, not yet. Everything is Coke. Very nice. Okay, let's march on. All right, so NLP research design, broad strokes here. We've got, we start with a research question. We collect data, we do preprocessing, usually some kind of modeling for analysis, and then interpretation of the results. That's the payoff at the end. I'm going to give you a metaphor to help make sense of this. And think of it like preparing a meal. And I really like making burgers. So let's say that you got a burger in mind. You really want to create a burger. That's the research question. I decided what kind of experience that I want. I've got something I want to learn about the world. In this case, I'm going to eat it. But in NLP, it's something you want to learn about the world. We're all scientists here. You know what a research question is. And I'll give you a couple of examples. They are domain specific, and you need to be able to use text to answer the question. So for example, what are the early warning signs of depression? How did different European nations react to the election of Trump? Do Twitter users react differently to mass shootings based on the ethnicity of the perpetrator? What distinguishes different styles of hip hop? And have any of these essays been plagiarized? We're going to talk about a method that would be applicable to any one of these questions. But the point is you start with something that is domain specific. Again, this is NLP is a broad tent, big tent, I guess is how you say it. And you've got a lot of different people, a lot of different, not just like political leanings, but disciplinary orientations, ways of thinking about the world and doing science that could use these tools. But you have to start in your domain. That's the research question. The next thing you got to do is collect your data. So you're going to the store and you got to buy the ingredients. If you like buns, you get a bun. You get some kind of grass-fed beef if you're like me, and you could go anywhere to do this. A lot of different sources, and obviously the parallel here is there's a lot of different text data out there, and we'll talk about what those different sources could be. So what do we want? Ultimately, we just want plain machine-readable text. It's relatively clean. You can think about things like hashtags or URLs in there. You can deal with that down the road, but first you just got to get the data. And how do you get it? You might already have it. That's if you're lucky, or you might know somebody that has it. I've done a project like that. I just emailed the creator and they were like, yeah, here's the data. Very nice. You could do web scraping. I could talk a lot about that, but the idea is whatever source of human readable text you've got on the internet, there's going to be some way to download it or some part of it systematically with minimal junk. Using an API, application programming interface. So something like, think Twitter, New York Times. I think Reddit also has one. You can say, here's my search query, the kinds of information that I want. Give me the 10,000 tweets related to that. Or just say, like, give me 10,000 tweets from today. OCR is another option, optical character recognition. That's where you start if you've got physical written text. Yeah, but regardless, you need to know where the data came from, because no data collection process is perfect. You have to be able to justify your choices. Okay, so let's assume that you've got data. The next thing you do is you pre-process it. You get it ready for analysis. Parallel here, you're gonna, well, assuming you got a loaf of bread you're using for your burger, you cut off the slices. This is not the main thing that you do. It's kind of like you take everything home from the grocery store and you're unwrapping it. You're getting out your cutting board, you're starting up the grill if that's your case, and doing things like slicing bread. So again, nothing irreversible here. Ideally, you keep the original data and then you play with it until it gets into the configuration that you want. And it's all before doing sophisticated models. And this is the first thing I'm going to say that is the main focus of our time together. Pre-processing and modeling are the two central parts of this workflow. The rest of it is really domain specific. So we'll talk a lot more about pre-processing and modeling than research questions, data collection, or interpretation. Okay, so what is pre-processing? It's got a lot of different pieces. I'm just going to throw a bunch of these at you. You're going to get some of this, and but you're going to hear it over and over again. Okay. So the first thing, well, these are mostly in order. Tokenization, you're separating the text into words. Sentence segmentation, also called sentence tokenization, you're separating a longer document into sentence chunks. Text normalization is when you turn everything into lowercase. You don't always want to do that, but often you do. Take care of spelling mistakes, removing special characters, think unicoding and other kinds of formatting that you don't want in there, replace URLs and numbers, etc. Removing stop words is another common step. And that's not done in every application, depends on what you're doing. Like especially if you're trying to learn about who's talking about whom, what they call dependency parsing. And and especially computational linguistics. Stop words are important because they connect different subjects. But usually you remove these words, things like and, for, but, where, to, these sorts of words that don't really have a substantive meaning, but are important in context of the original utterance. Another common thing, stemming and lemmatization. These, well, stemming is removing the morphological affix. Lemmatization is like finding the root word. And again, we'll talk more about this. Part of speech tagging, POS tagging, assigning a part of speech category to each word. Syntactic parsing is changing the sentence into like a tree structure. So you've got the original sentence, and then you can break it down to the subject, verb, object, and different classes, and sort of groupings that way. Chunking is a shallow version of syntactic parsing. I haven't really done that much of this work, but it's common. And named entity recognition, where you can identify proper nouns in a text. And there's all kinds of different ways to do each of these steps. We're going to walk through some of the most common ones. So you've got kind of like a pre-baked recipe, but knowing how they work is also important. So we'll do some of that. Now, why do we do this? Well, you can imagine if you just download a whole bunch of tweets, they're going to have a lot of junk in them. And then if you leave that junk in them and then try to run your models, what people say is garbage in, garbage out. So you could end up with some really messy topics that where a supposedly conceptual grouping of words is really just a bunch of URLs, or another group of words is just words that don't mean anything. Stop words are also really common words. So preprocessing is a solution to doing NLP that doesn't result in anything useful. It's essential. Okay, so counting words, yeah. Well, of course, yeah. Identifying the words in a text. Even just to count words, you have to do a lot of cleaning, preprocessing, such as tokenization, stop word removal. And you can also identify which words are important. Okay, also preprocessing helps us get to know our data. You have to look at a lot of these sentences, see what your different techniques are doing. Often you would look at frequencies of which words are the most significant. This is kind of, it can be part of a hypothesis generation approach if you're going more inductively. So exploratory data analysis can be an important part of this. And yeah, and often you'll learn that your data is broken, or that there was something conversion error when you moved it from Excel to CSV to Python or something. That happens all the time, and I've wasted a lot of weeks trying to fix these sorts of problems. So learning to do it right really will pay off. Okay, this is what tokenization looks like. Your original sentence is friends don't let friends make word clouds. That is a niche joke. I don't know if I'll explain it, but the idea is you've got a beginning of a sentence, you've got the words separated out from each other, and then you got the end of the sentence. And this is an HTML markup. You might recognize this, don't worry if you don't. The point is each element of the sentence, each token is broken out, separated from each other, so you can analyze them separately and put them in one big bucket. Okay, another thing you're hearing about a lot is n-grams. So these are fixed length chunks of words that appear in order within the text. So if you've got what they call unigrams, this is a sentence here. Each of those is a separate token. If you've got bigrams, this is a and a sentence are all chunks together. And if you've got trigrams, this is a sentence are your chunks there. So you're kind of increasing complexity by getting the bigger units, but you also often do a better job capturing phrases, context-specific meanings, yeah, and grammar as well when you do it that way. Okay, another very common thing you'll see, and we'll play with this, is a document term matrix. And that is exactly what it sounds like. You've got the documents on the top, the terms on the side, and their intersection in this matrix indicates how many times each one occurs. So in Hamlet, this is the toy example, but in Hamlet, let's say the word knife occurs once, the word sword 17 times, the word like 75, and in Tempest, the word dog occurs twice. I can assure you it doesn't, but again, it's just an example. And these, so this is one notion of context. In this case, it means they are occurring in the same document. So again, words are rows, documents are columns, and entries are the number of times the given word appears in the document. And it's a way of encoding information about the distribution of context the word appears in, assuming that words of similar context have similar representation. So Knife and dog. Well, let's look at a real example here. Love and like occur together a lot of the time in Hamlet, and in Richard III and King Lear. So are those words related? I mean, they should be, right? So we can infer a semantic relationship based on their co-occurrence in the text. They show same document. Right, so an important step here, let me just unwind 1 second, is that what the document term matrix shows you, it's a matrix. So actually each dimension of it, each direction is a vector. So the documents can be represented as a vector. Here's the words that are used in Hamlet, and here's the words used in King Lear. And this is useful for a lot of different applications, including word embeddings. So just be aware of that sort of conceptual connection there, the matrix and the vector, the whole and the part. Whereas a word vector is knife and all the text it occurs in, and same for sword. It's a vector representation, whereas the vector size is the number of documents the word is used in. All right, so one more connection here. Term frequency inverse document frequency, called a TF-IDF, is sort of a weighting scheme used to help document term matrices be more useful. So if a word occurs in a given text very frequently, like it's concentrated in that text, whereas that word occurs less often or very little in the rest of the corpus, then that word gets a really high weight because it's important to that text and it's rare. So high term frequency and low document frequency means that the word gets a higher weight. So just get that intuition there. The word algorithm is going to have a high IDF, inverse document frequency, the denominator there. If it's in just one document, whereas the word you, even if you don't remove stop words such as you, the IDF will be very small, which gives it a lower weight. So there you go. All right, so next step in our research design metaphor is modeling. That was all pre-processing. Now you're finally like, you've got the grill started up, you've got your patties created if you're following me here, and you've got the mustard and everything out, so you can spread it on your buns if you want. Right. So what does that look like? Different approaches to modeling. One of the first things you got to think about here is that different models require different inputs. So whereas topic modeling, which we won't talk about the mechanics that much, just how it's used. The input is a lot of different texts, and the output is some sense of what the texts are about. You could throw in a lot of newspaper articles, a lot of emails, whereas classification is a whole different ballgame. What you need is lots of different texts, but also hand-labeled categories. So for instance, whether this speech is written by a conservative or a liberal, or whether the Reddit request for a pizza yielded a pizza or not. So hand-labeled categories, and the output is something that, well, is the category. Okay, fair enough. It's a classifier. So you create something that can tell the difference between Republican speeches or Democrat speeches, for instance. So yeah, hand-labeled bunch of documents, for instance, separating into spam ham or positive negative reviews. Yes, right. So for instance, let's say you've got 10,000 tweets, and you want to ask some pretty weird question about them that computer wouldn't know about. So leaning left or right is fine. You would then code a sample of them and then train a classifier just based on those, and then use that classifier to code the rest of them. So it's a way of reducing labor, basically. You've got lots of different texts. You need something that can tell you, without you having to read all of them, what categories they fall into. Okay, and again, a text could be lots of different things, a book, a tweet, document, and so on. All right, yes, and for modeling, often we're using something we call the bag of words representation. So here you've got just a toy example, a movie review. It manages to be whimsical and romantic while laughing at the conventions of the fairy tale genre. Lord, what are they talking about? I don't know. You think of taking all those words, all those tokens, if you will, you put them in a bag, and you just shake the bag up and mix it up so that word order is annihilated. What you end up with is just a lot of information about token counts, word frequencies. The word it might occur 6 times, the word sweet might occur once. Okay, I'm assuming you're with me, but I'll ask you you'll have a chance for questions. And if you have a question in the meantime, throw it in the chat and I'll get to it in a bit. All right, so again, frequent words, very common thing we do. Often this step alone tells us a lot about a text. So if you're interested in Trump's tweets, this is what they look like. I forget what sample this is based on. Okay, this is not definitive, but it's just an example. So individual words in Trump's tweets from some period of time, he might use the word people 300 times, the word jobs, what is that, 150, not surprising, and border 100 and something times. So that's just word frequencies. The colors are nice. It's actually a very simple method and output. And it uses the bag of words method because these words are not connected. They're separate from each other. So context, again, is ignored. Okay, some common methods for modeling NLP beyond just word frequencies. Dictionary methods is a common one. We're going to play with that. If you've got a list of positive words, list of negative words, you can count them up in a text. This is the proportion of words that were positive. This many were negative. You call that sentiment analysis. It's the subclass of dictionary methods. Another common thing I'll show you some examples of is distinctive words. So yeah, and there's a lot of different methods for doing this. But you can imagine you've got a corpus of speeches by Republican legislators, Democrat legislators. You want to ask not just what are the most common words in either one, because those might be the same thing, but you want to ask which words are different between the two. And that's what this method tells you. Classification, again, using some features of the text to sort them into categories, like whether it's spam or not. And topic modeling, you get a mixture of words over topics, topics over documents. That's a little more technical than you need to get, but basically, what is each text about by assigning each a weight of topics. Word embeddings, you represent each text by a numerical vector. Then you can do all kinds of fun things like look for words similar to a given word, and also represent each text. I'm going to do complicated. Using vectors to represent text. That's all you need to know. Clustering, yeah, clustering is like topic modeling, except each text goes into one bucket, whereas a document and topic modeling could have like lots of different topics and each one has a weight. In clustering, you say that each text goes in bucket A, B, C, or D, and often you only have not that many clusters. Again, that's all I think all I need to say, but the input for that could be DTM, that's document term matrix, or TF-IDF, or there's lots of different inputs. Alrighty, here's a complicated looking tree for you that breaks down when to use each of these things. And I don't think we need to torture ourselves over this. It's a really useful tool. So this first thing to think about is, do you have digitized text? Obviously, if you don't have that, you can't do any of this stuff because you need plain machine readable text, right? If you're interested in the text of the content of the text, that's also an important question. Because if you're not, you can do something simple like cosine similarities. And often they use that in plagiarism detection. It's like, is a given essay that a student gave me is very similar to anything else I've got in my database. Very quick tool for telling you whether or not this paper has been submitted before and therefore is plagiarized. If you do want to know about content, are you looking for specific categories? If you are, you're going to classify them into the categories like we talked about. If you're looking at categories that could overlap, you might look at dictionaries here, like sentiment analysis. Positive and negative aren't mutually exclusive. And number of categories, and is it likely to contain just one topic? Okay, this is just a resource for you. These slides are in the repository, so you have access to them, and I'll make sure everyone gets that link. Yes, I think that's enough for now for this. There you go. Now, a bit more on dictionary methods. Again, you could get some percent that's negative, some percent that's positive. And one example of that is a lovely experiment from an online journal that looks at the average happiness for some set of respondents through the week. Sorry to say, if you thought Wednesday was hump day, Tuesday's even worse. Looking at the happiness for these folks. People are getting excited on Friday for the weekend, Saturday, it's the weekend, Sunday, oh my gosh, there's another week coming. And then you're deep in it, especially on Tuesday. Okay, so again, that's sentiment analysis. You take something about their tweets and you can measure their happiness through the week in a pretty amazing scalable way. Okay, you talk about dictionary methods. Often what people will tell you, especially if they're in psychology or psycholinguistics, is look at Luke, linguistic inquiry word count. A lot of dictionaries in this one dictionary. So they're not just interested in like the sentiment, anger and sadness are in here. They also break it down to a lot of different like linguistic properties like past tense or future tense. Quantifiers and numbers are in here, whether they're talking about leisure and achievement. So a lot of different things. It depends on what you're interested in. I think it's commonplace to just throw a big dictionary like this at a group of text and see what happens. I have to tell you that thinking through it before you do that is really useful. And yes, some exploratory analysis is great, but this can be kind of overwhelming and give you a lot of useless information unless you narrow in first. So do that is my takeaway. Okay, but we'll come back to something sort of like Luke a little later. Distinctive words, here's some examples. This is something from the New York Times. They took, I mean, they of course have this massive proprietary data set of essays that were published or not published, and that were written by male or female authors. So you can kind of compare each of the different quadrants here. So for male authors that were published, they talk a lot about father, people, talk, and looked. Okay, that makes sense. Whereas if they're not published, talking a lot about time, how busy I am, maybe. Published female authors, talking about children, mother, marriage, and boyfriend. Gender norms, anybody? And whereas if they're not published, talk more about love, life, feelings, familiarity, and mom. Make of that what you will, but I just think it's really interesting to break things out this way, and what a nice visual presentation, right? New York Times is great at that. Okay, so this is also a useful data exploration exercise. So if you've got a meaningful way to distinguish aspects of your corpus, like left-leaning, right-leaning, or published by males and females, you could do word frequencies, stack on top of that distinctive words. Not an uncommon way to do it. Data exploration exercise, and also help you select features. All right, one more example of distinctive words that might look familiar to those of you that follow the Massive Data Institute and their work. This is from the surveys of people asked what they remember about the two candidates based on recent news and what they've heard on the radio, whatever it is, read, seen, or heard about Trump, about Biden. And this is from mid-September. So for Trump, a lot of what people are talking about and thinking about, what they remember about him is the coronavirus. Other people thinking about schools. And then there's a lot of other stuff, masks, US border, other things. TikTok is in there. For Biden, what people are thinking about is Biden, and chose Harris. So what people say is that some things are sticking and others aren't. The reason we can tell that story is by looking at distinctive words. And this is a pretty sophisticated algorithm. I don't have to tell you about the details, but you know, the z-score means the log odds basically of this word occurring in a given survey of people, whether asked about Trump or about Biden. Now, something on classification. So you could take in some digitized text, right? Something like a tweet or a comment on a YouTube post or whatever. And then based on that, you want to classify it, for instance, as spam or not spam. Okay, so that really matches emails better, but it could also classify robots, for instance, in Twitter. And one application of this you could think of, this is stance. So the blue line represents people's stance toward Biden. The red line is their stance toward Trump. And this is from the first debate. And so we looked at all these tweets leading up to and shortly after the first debate, especially during, and kind of looked at the like when things happened in the debate and how it reflected people's or impacted people's preference toward the candidate. So strongly pro or against. So stance is not sentiment. Are you for Biden or against Biden? Are you for Trump here at the top or against Trump? And again, if you had to look at every tweet and classify it that way, it would be painstaking and take a really, really long time. So they trained a classifier. And so these are the main moments through the debate that change people's minds. Debate started, they're insulting each other, but somehow Biden makes the climb and Trump stays where he is. Again, application of classification. And here's one of topic modeling, again from the MDI work. And this is not strictly speaking like a traditional topic model, but it's very similar in the output. How much of Trump's tweets are about a given topic? Coronavirus, more and more. And protests, pretty little. Supreme Court had a huge climb around RBG, declined. Debates kind of is still trending. So yeah, okay. So for a given, you might look at a given tweet and it's going to be about something about the coronavirus, something about Supreme Court. All these things could be in there, but you can also add up all of these weights for each of the topics to ask at a given date, which one is he talking about the most? All right, so we finally, we finished talking about modeling, and now we've got our burger, and this is the opportunity to eat it. So to taste the experience you asked for in this world, in this metaphor. So, right, so you got your, you decided what you wanted to do. You went and got data or materials to make it happen. You processed the ingredients to get ready for that. You prepared them in the way that you needed and did that iteratively and carefully as modeling. And then you've got the results and you can interpret what you're seeing. And I'm painting this as a straight line, but these things happen recursively. You might make models and then decide you need more data. You might try to interpret what you found and realized it's really weak. You need to change your analysis strategy and so on. All right, so last thing in this process is interpretation. So using the insights that you've gained and try to understand your question, try to answer your question. So in classification, for instance, this could mean looking at words with high coefficients. Those are very important for determining whether a text falls in category A or B. So an example, people with depressive symptoms are more likely to talk about abstract concepts and use more negation. So depressive symptoms here is the characteristic of the text, something you can identify in the text, a feature, if you will. In topic modeling, this could just be based on looking at the topics. In Germany, the main theme centered around taxes and immigration, while in France, people were more concerned about racism. So the nation, the tweets, or the nation that the text came from, the cultural context, could influence, as well as many things about that, political environment and so on. Topic modeling can tap into that. Okay, so to review, we just did that. You ask the question, you get the data, you pre-process it, you prepare it, you do some kind of analysis, and you interpret what you got. Okay, now I'm gonna throw it at all of you, my lovely 29 people in the room. What questions do you have? What's not clear from what I've spoken about? And I think I might have seen something in the chat, so let me check that. Oh, here we go, something from Sabia. How can we reduce the human bias when deciding what attribute to assign to word or sequence of words? Interesting. For instance, in the case of the Republican Democrat divided Twitter, it probably required some human decision making about what words a Democrat is likely to use. That is that's an interesting one. So how do you make sure that your, what we call the training data, the stuff that you code by hand, is coded reliably? And how can you wash out bias from that? I think one of the most common, this is not strictly speaking NLP, but one of those common solutions is to have multiple people code them, so that they then compare their codes and can kind of gloss over some disagreement. So I'm doing that right now in a project. Me and one other scholar are reviewing a lot of articles in organizational theory. And we're coding them as like, does it engage this idea or that idea, this theory or that one? And I've got one idea about how to interpret what that means, or with what breadth to interpret the codes, right? Like if they mention the word culture, is that enough for them to go into what we're calling the cultural theory? I tend to say yes, and she says no. So we got to hash it out. So that's one way of reducing bias. Deciding yes. So yeah, so I think that's true though. I mean, it's nonetheless true that human coding does bring error into the process, and can also bring in a lot of useful information. Christine says, can you elaborate a bit more on inverse document frequency? Yeah, we just ran over that. We will you'll see the formula actually and get to play with it tomorrow. So don't worry too much about it. Yeah, but inverse document frequency means for a given word or token, how much of the corpus of all the documents that you have does that word occur. So you could think of, if you want to decide how, like, what the weight is for a word in a document, if the word occurs a lot in that document, but doesn't occur in the rest of the corpus, then the weight would be high. So think of it as like how densely represented a token or word is in one text versus the whole corpus. And again, we'll get to that more later. From Helen, regarding bias, perhaps using self-reported labels such as voters who registered. Oh, it's her answer to Sabia's question, I think. Yeah, no, that's interesting. I mean, if you're trying to classify, it's actually a little hard to classify just like tweets as being left or right unless they identify themselves. But yeah, you could use that as one check, which party they're identified, like which labels, which hashtags that they used. Well, also looking at their descriptions. I don't think I need to go into that anymore. Maxine says, is there a rule of thumb for how much hand coding you need to do? That is a great question. Everybody wrestles with that. I'm gonna like give you a terrible answer, and that answer is 1,000. Because generally that's okay. If you've got something on the order of 1,000 texts that are hand coded, you pretty much can train a classifier. I mean, heck, like sometimes depending on where in your process, you could just have like 10 and train a classifier really badly, and then use that to select more text that you're going to hand code. And that would speed up your process. But yeah, I don't know. I want to give you a better answer about like the power law or something. Like you can use that in social psychology. How many experimental subjects do you need? But I'm not aware of any hard rules in that case. But that just gives you a sense. MK, how to include the misspelled words but uniquely distinct words in DTM? That's a great question. I mean, let's see, close, what do you call this? I don't know, close manual analysis of the data is going to tell you which words occur frequently that actually are misspelled. And you can incorporate some expressions that correct those, that fix them. And there's actually some pretty cool algorithms that like look at a given word and it's like, okay, is this word really rare? Okay, well, can I transform it into a common word by changing one character? And if it can, it'll try to do that. So there's ways to do that. It's a little, it's in the nitty gritty. So we don't do that here, but I can point you to resources that do if you want to use it. Data aggregation, go Helen, use on a roll. Abby, in the interpretation step, are you also taking into account who's included and not included in the analysis and whether or not that can generalize to the entire population? Very good question. For example, not everyone uses Twitter. Yes, that's a great example. Twitter is not a representative sample. For sure, I mean, that doesn't really fall within our, I mean, causal inference is a huge topic. For sure, thinking about your sampling frame and who you can talk about reliably based on your sample. So I will say, though, that something called post-stratification sampling, like for a lot of social media applications, is something that can help your results generalize. There's a great study that used Xbox users, which is not a random sample, but then they weighted their respondents based on, so like there might be like 1% of users of Xbox that are Black females, but yet they represent something like 10% of the population for some area. Then you upweight each of those people and their preferences or whatever information they gave you, and then you can get something that's pretty close to the truth. And this has been shown. It's pretty cool. But definitely thinking about generalizability is important. And then Christine, will we delve more into distinctive and modeling? Distinctive word modeling. Let me think about that. Yes, we do some of that again tomorrow using TF-IDF, really cool tool. So that's all I see, and this is a really good time for us to take our break. And I'm gonna stop my, actually, what's next here? Yeah, so hopefully you are, this is the repository, by the way. Hopefully you've loaded up your binder, but I'm gonna encourage you to leave that there for 5 minutes and get up and stretch. And I think what I'll do is get out of here. And oh, this is my binder. This is where you should start. But let me point you to the repository. And I'll just leave this here for a second. And again, I encourage everyone, please get up and stretch. And we'll be back in like, let's say 4:00. Let's make it 4:05. We have our time. I'll see you shortly.
Can you show the link again? I joined late.
Yeah, I'll put that in the chat.
Thanks.
you can hear me, please give me a thumbs up in your participants window. I guess you don't have a thumbs up. Okay, give me a yes then. All right, we are trickling in. Don't be shy there. But yes, I do see one more question here. Sample. Okay, I will get back to that in a minute, Muriel. But let's march on. So your screen. Let me share my screen again. It should look like this. If you are not here and it's not loading properly or something like that, please give a shout out. I forgot to mention that Agaritza and Doug here are, I'll say Doug Post in case there's another Doug, I haven't checked, are here as our helpers in tech support. They're experienced with NLP, they know how to work Python well. So if you're having whatever kinds of tech issues with packages or anything, please send a direct message to them. You can also just shout out in the chat, and one of them will help you out. And okay, Casey's using a different system. That's all right, as long as it works. We'll see what happens with the versions. All righty, so here's the thing. You start here, and there's a lot of different things to look at, but for our purposes today, just go to day one. You'll see that the slides are in here if you want to review those again later. You don't need to worry about the data. Just go ahead and click on preprocessing.ipynb. It takes a minute to load up. Oh, I didn't realize I had a visit repo button here. That's it must be new. Okay, and this is one of those things where I want everyone to be together. So please please give a shout out, give a yes if you're on the same page. And thanks for clearing your screens, folks. I'm clearing the yes, but give me a yes if you're here with me. Okay, I see a lot of folks are, so we're gonna move ahead, and I see that okay, even more are saying yes in the chat. That's cool. All right, so preprocessing. This is what a Jupyter notebook looks like. Hopefully you've seen one before, and they're very easy to use. If nothing else, rule of thumb is hit Shift Enter, and whatever cell you're on, it'll execute. But you'll get some time to practice. So text data doesn't come clean. We have to clean it up to make it ready for any kind of analysis or modeling, as we were talking about. And there's as many ways to do this as there are ways to analyze data. In other words, a lot. And there is no one-size-fits-all approach. If you get much experience with NLP, you'll probably find some modules, packages, or programs that offer you defaults. So there's one that I used in R, it's called structural topic modeling, and it would automatically remove stop words and eliminate words that were below a certain frequency threshold. You need to know absolutely what those things are doing. So even if you end up using them, having these kind of building block toolkit of looking at tokenization and everything else will really be useful. Okay, so yes, for some applications, you only need a bag of words. So more preprocessing means clean, it means better. In other applications, like I mentioned about word embeddings or syntactic parsing, you want to keep stop words and punctuation often. So it depends. All right, that's what that's about. Our goals, again, are to get an introduction to NLTK and some NLP terms, learn about preprocessing choice points, learn about different varieties of counting, and practice the basic ingredients of text preprocessing. And this is an interactive outline. You don't have to click on anything, but if you get lost or you want to skip around, you can just click on document term matrix, and it brings you right to that part of the document. So don't do that. Come back with me to the beginning. And yeah, so I'm hoping everyone has some Python background. I'll give you a little bit of experience, a little bit of practice rather, with some of the basics. But yeah, there's also going to be some challenge in here that I encourage you to use what you know and to be creative. All right. Yes, and just a note on regular expressions. Don't worry if you haven't seen this before. It's actually an exceptional tool for not just Python, for any kind of NLP that you do, even like the command line in terminal or something. It's useful. So we're going to use that, but it's very simple. We just use re.sub, which is a substitution. And don't worry about it. We'll get there. Yeah, so just a note there. And then there's some vocabulary and stop words. We talked about these things already. So there's there for reference. All right, first thing, reading in files. So we won't take a lot of time on this, but data has to be stored, right? Often, these are some of the most common formats in which it might be stored. So again, you come to this one cell here, and you just hit Shift-Enter, and that should be done for you. So there is now a raw variable, and you can take a minute to do something like ask yourself, what is the type of this variable raw? Oh, great, it's a string. You can ask yourself how many characters are in it. A lot, 700,000. You can ask yourself, what are the first 1,000 characters of raw? Oh, look at that. Mostly a preface to a Project Gutenberg free ebook. Isn't that nice? That's how we can use these because they're free. And then slightly more complex question, join together the first 200 characters and the last 200 characters. Let's see what that looks like. Interesting. Okay, so I just did that for you. I'm helping you with review. But anyway, that's some of the basics of how to work with objects in Python. Let's do this again. Reading in CSV. Go ahead and hit Shift-Enter. This reads in Trump tweets, a sample that's not super recent, but it feels like this Trump tweets was a thing that started ages ago. Standard approach to opening files, yes. Oh yeah, we do this with codecs because there's some funky encoding errors if you don't. Just take my word for it and play with it if you want. Okay, I'm going to challenge you now. I'm going to give you a minute to answer these questions yourself. So just like I did above, I've got a tweets object now. What's the data type there? How many entries are in it? Which entry is a header row? Get the first 10 and then join the 5th and the 10th ones. Try it out. Don't worry if you're not up to speed yet, but at least try to use what I did above there. And again, I will just leave my screen here. And I'll just give you like 2 minutes to answer these questions. I'm leaving this up for you to cheat with. So please go ahead. And if you're not sure what's going on, send something in the chat. Okay, let's call that good. We're just trying to get a general review here. Can someone tell us, how do you, just walk us through this? How do you tell what data type tweets is? And just shout it out.
Type tweets.
Very nice. How many entries are in tweets? How do you, tell me how to find that out? Anyone?
Len tweets.
All right. And which entry is the header row? Anyone?
tweets square bracket 0.
Very nice. And Python is 0 indexed, so 0 means the first one. There you go. There's the headers. The first 10 tweets, how do I index that?
Square bracket :10.
Very nice. And how would I merge the 5th and 10th elements of tweets? A little more challenging, isn't it? So I'm gonna, how about we take the 5th one and then the 10th one. What do you think? Is that right?
Are those actually the 6th and 11th because of the 0 indexing?
You're really on the right
Actually-
track there. Anyone else? Yeah, it's kind of weird to think about, isn't it? So, oops. If we look at the first 10, see the first one's the header, right? So the first tweet is actually indexed 1, and then second tweet indexed 2. So strangely enough, that works, even though it seems wrong. Most of the time, assuming the tweet 0 was actually a tweet, you'd actually do 4 and 9, because you think about it like it's shifted to the right. That make sense? Is anybody confused? Okay, well, that's a little bit of stretching for you. Let's do one more reading in of things, or maybe 2 more. Shift enter, this reads into tweets the same data, but in a very different object. So just to roll on through this, the type of tweets, it's now a data frame. And just so you see what that looks like, there's your reminder. This is pandas, so it's in a data frame, or basically a matrix format. And the header row is now here. And how would I get the first row of tweets? Anyone? How would I get the first row from this data frame? Feel free to throw it in the chat. See, Julie and Alan were already contributing. Well done.
Tweets.head. 1.
First row. Tweets 1, you said?
Dot head.
Oh, I see. Like that.
Yeah.
Nice. Okay, so which row is that actually? It looks like today we express. Yeah, you got it. Very nice. Whereas if I did 0, I would get the header row. Okay, and to get the first 5 entries, I would just do 5. All right, just moving ahead here. You'll get some challenges in a minute. I just want to make sure we keep a good time. Again, reading multiple files, there's a very interesting or useful package here, glob, that takes a directory and gives you all the file names that are in that directory. And there's simply too many of them. So I'll just get the first 20 to show you what that looks like. Oh, these are just the Austin ones. So there's only 7. Okay. I'm going to ask you to think critically about this a little bit. Take a minute and try to answer these questions on your own. And this looks at the OS package a little bit. I think you can see what it's doing. What type is F names, and it has various steps along the way. How many files, and what type is Austin. I guess I already told you this part, but you can answer the rest of these questions. So take a minute, try to do that. What I encourage you to do is just try to work with this. You might need to break it up or add some statements in there to figure out what's happening along the way. So go ahead and take a minute, try to answer these questions. All right, so feel free to shout out. Just put it in the chat here. What are what are you thinking here? Whoops. What is os.path.join doing in this code? Very interesting. Valerie says creating a string. That is true enough. So it's also it's exactly creating a string, and it's a string that gives an absolute path to a series of files. So if I take that thing that it's doing, and I just want to see what the output is directly, indeed a string, and it takes us. It's actually I mean, technically it's a regular expression because it has the wildcard in there. Takes us to any of the files that are in this folder that match this pattern. And Henry says, looking for everything in the folder Austin with the suffix txt. That's exactly what that's doing. Well said, Austin. Okay, what type is fnames assigned after is first assigned a value? Well, string, you got that already. What type is fnames after is assigned a second value? What do y'all think? It's a list. Got it. Got it, Valerie. So if I did just asking what's the type of fnames here? 7 files, and what type is Austin? Last question here. What do y'all think? It's a string, exactly. Just a moment. All right, yeah. So what this is doing, it creates an empty string, and then for each of the files here, it opens it up, reads it, and adds it to the string. So we end up with, whoops. Actually, probably just easiest to do type Austin. Yeah. Or say you want to see the first 100 characters of the string. There it is. Same as what we saw above. Very nice. Okay, now for a challenge. This is, intended to take a little longer. I've asked, or I've posted a couple of hints here to help you figure it out because there's a lot of different files and things. So I'm going to give you like 3 minutes, and what I want you to do is go to the folder Amazon, extract out just the text column from the first 2 files and store them in a list called reviews. It's just a couple lines of code. If you're not sure how to deal with this, there's hints here, but you can also navigate to the files directly by going into this browser thing we started with, looking at data, looking at Amazon, and then you can open up one of these, and they're probably quite long, but that's what they look like. But anyway, do that only if you have to. I'm going to encourage you to work with this here. There's a list of what's called columns and so on. So please take 3 minutes and try to load in all these CSV files. It's meant to be a challenge. Don't worry if you can't figure it out right away. Just stretch yourself a little. Go ahead. Take another 30 seconds or so. Try to wrap up your answer. All right, so with your thinking caps on, what's the first thing that we need to do here if we're trying to load a bunch of different files into one list called reviews? Oh, Kristen has an idea, import libs. That's not the solution I had in mind, but maybe you can tell us what you have in mind. What do you do with libs? Oh, I see what you mean. Yes. In this case, Kristen, we got pandas already, so there's not really anything else that you need, but you can, there's certainly other options. So Julia sent us some code. Okay, Amazon names equals Amazon names. Interesting. Okay, so the first thing we actually really need to do is initialize an empty list. So the challenge says put in a list called reviews, so there it is. And now we need to add to it, right? So the data directory can be something like what Julia sent us. Let's try that out. So Amazon names, and then if we're on the right track, Amazon name should be something like what we saw before. That works. And then we can use glob to get us all the file names. Oh. I already executed it, so it'll give me an error unless I do it separately. Oh God, that's terrible to look at, but yes, there it is. Okay, so now we've got a list of all these different files to load in. And how are we going to load them in? Anyone else have who else has an idea or a tip for how to do this? Are we going to type in each of these names and then try to add it to the reviews? Well, there we go. Helen's on the right track there. So for loop is a good idea. So you don't have to deal with each of these individually. You do it in a loop. So there we go. And I'm just going to use Amazon names because it's already there. What's next? Okay, looking good. So I'm going to call this df for data frame. Read in the CSV like we did above. Fname header equals none. And why are we using header equals none? Because some of them don't have headers. So yeah, we can try this out. Let's see how it goes. And then let's look at data frame. Oh, okay, that's silly. Why is that silly? Yeah, Doug is helping us out. Thanks, Doug. Yeah, for keeping us going along the way. Yeah, so really we want to, well, that's one way we can do it actually. Got the data frame and want to append to it the review. There's one more wrinkle in here, and that's that the review is one column in here. So I'm not going to append the whole data frame, and I'm going to append column 9 because unless I'm messing up my syntax here, I believe column 9 is just the text that we care about. Yeah, that looks right. So let's try this out. Again, just initialize, create the list, look at the list, and then extract just the text and put it in this list that we care about. And there it goes. Oh wait, that's not right. Oh no, I asked the wrong question. I want to look at reviews. Try again. Okay. Oh, I see. We've still got a weird list here. Append. What we actually want is just the text. So then let's try this. Reviews.append text. Oh, you know what? I think this is another simple Python thing. We don't want to append the whole data frame or the column. We just want to attach the text for each one. So let's try that. We're getting there. Okay, so this would basically work. It's not quite a list yet. It's a bunch of data frames. I forget where this is going weird. Might need to do like
TF9.values, Jaren.
Oh, there you go.
That's a series, not a
list, right?
no parentheses.
Yeah, same weird thing. I forget how I did this differently. In the solutions, there's a better idea, but this basically gets the text. In fact, I think I'm going to look at that. So if you want to, you can go to the solutions folder, and that's there. Because I'm really not remembering there's a trick to this. And then we're going to charge forward. Reading in multiple files. Header equals none. That's all the same so far. Yes. Oh my gosh, I have to coerce it to a list. That's what I'm forgetting. Okay. I think if I do that, I don't even need values. Let's try that. There we go. Oh no, not yet. 10 plus. That should work. I'm not sure why. Okay, anyway, we got close enough. We stuck it in the list, and even though the formatting isn't ideal, this is one of those things where syntax really matters. I can't quite figure out what's going on there. Oh yeah, it's looking good at the bottom though. Anyway, charging on. Okay, tokenization. So, gosh, I'm aware of time, so we're going to probably just bulldoze through some of those challenges, but let's get the basics, okay? Once you read in the data, some has headers and others don't. That might be it, actually. I don't know. Yeah, we need to experiment. I encourage you to do that. And the solution is there in the notebook if you want to see it. All right. Tokenization, we split a sentence or a document into individual words. And the difference between a token and a type is that a token is like just the occurrence of a word, but a type is like a unique word. Like the word the occurs however many times in a document, but the itself is a type that can occur in multiple tokens, if that makes sense. So here's an example. The dog ate the cat has 5 tokens. The dog ate the cat, but only 4 types. The only counts as 1. Dog ate cat, so there's 4. Okay, there's a lot of different approaches to this. One of the simplest ones is to split on white space. So again, we read in a document, we take a look at it, and then we can just use dot split. Very simple string operation. So it's dot split the text, look at the first 20 elements. Okay, so there you go. So you might notice from looking at this that splitting on white space is very nice for the white space. It doesn't take care of some other things. What do you notice about this that, doesn't seem ideal as far as like representing a sentence through a list of words? Julia nailed it. Keeps punctuation. Yeah, so tokenization period counts as a separate, not just token, but a separate type. It's a whole different thing than tokenization with a capital T. So we've got casing is still an issue, punctuation is still an issue, and then contractions are still in there. So ideally, we want to collapse these things as much as possible. Tokenization should be under one type, not two, because then the computer is going to think these are fundamentally separate things, and we know that they're not. So do better, computer. And now, yes, another way we can do this is with regular expressions. So again, this is our simple application here, just using re.findAll. So there's a pattern, anything longer than one white space, or one white space or more. And it splits it up this way. You notice it takes care of the punctuation here, but there's still capitalization and does this weird thing with contractions. Okay, so interesting. One more option here, and this is actually my preferred because I'm just not used to it as much. I haven't used regex as much as like anyone in like a CS or a DH community. So I always like NLTK. It just keeps things simple. Go ahead and run this cell. It'll download something really quickly. And then what this will do is separate out the punctuation. Weird thing here with the contractions. And oh yeah, it cut it off at a different place because of keeping punctuation. Okay, let me think about this challenge here, sentence segmentation. I think I want you to do this one. It's simple, gets you working on something. I might just skip the next one. So a while ago, we read in this object called Austin. And just to remind ourselves what that looks like, here it is. It's got this many characters in it. So tokenize Austin with any of these methods, regular expressions, word tokenize from NLTK, or just dot split, the string method on white space. I want you to find all of the unique words or types, and then sort them to create a vocabulary using the sorted function. So there you go. There's a bunch of hints right there. Try it out. See what you can do. I'll give you 2 minutes. Okay, let's see what you got. So we've got Austin here. You want to tokenize it. How'd you do that? Okay, looks like Henry has a couple different solutions here, but most of you use word tokenize. Okay, let's see what tokens looks like. Nice. Okay. Nice. Okay. So, and this is sorted alphabetically, so it doesn't really matter. We see that much punctuation. It's just in there. But then you got the apostrophe words. Very nice. Okay, let's charge ahead here. Was there anything we forgot? No, we sorted, so we're good. Sentence segmentation. Different ways to do this. Just like tokenizing words, we tokenize sentences. You can do that using periods. Oh, I probably overwrote this or something. Text. Let me go back up here for a second. Tokens. Here it is. Okay, now let's try to split this toy sentence on periods. Oh, there you go. So now we got well, it looks like 4 supposed sentences, but it cut off the new line, unfortunately. All right, we could also do it with regex, which lets us use different sorts of characters, periods, question marks, exclamation marks. That works too. It actually works a little better because it captures the question mark. And then there's sent tokenize, which does not make the new line error and also strips the white space better. Okay, so here's another question. Try some different sentence segmentation. Yes, this is nice, gives you a little more practice, but I think we're going to prioritize other things. So let's just move ahead here. And you can come back to this if you want more practice after we're done. Another really common thing, this is like, yeah, always need to think about this when you're working with text, is how to deal with punctuation. So one common list of punctuation we can use, there's one from NLTK I like, but this one's okay too. Is this from just the default string package in Python. And then you can make a new object for text by removing punctuation from it, and it looks like this. So we are, as in contraction, becomes just were, and it keeps the new line but gets rid of periods and such. All right, one more common thing here is to deal with white space. This has got a string here with white space at the beginning, at the end. If you just throw dot strip at it, it takes off the extremes, any extra spacing at the beginning or the end. And here's another example text, and we can load it up. So what do we do with this? We've got all this white space in the middle here. It's not just the beginning and the end. So if we do dot strip, yes, it cleans up the end, but there's still all this stuff in between. Well, regex is also really good at this. So to strip white space, you just create a simple pattern here, R to indicate the pattern is starting, /S means a space, plus means 1 or more. So then you substitute 1 or more with just a single space. That's what this is doing. And then strip it, and it's actually much better. Okay, I'm going to throw a couple more of these at you, and then you'll have a chance to play with them. Text normalization is another common step. You need to deal with uppercase versus lowercase, as well as, especially in social media, URLs, digits, and hashtags. And sometimes we remove infrequent words, depends on what you're doing. I don't do this here, but it's in the extra/preprocessing extra notebook, which is again referenced at the bottom of this one. But anyway, there's extra stuff in there, including removing infrequent words. One more toy file here. Let's read it in, see what it looks like. It happens to be about casing. goes Go figure. And then if we lowercase it, it's really simple to do. That's what it looks like. Okay, finally a challenge. So you just learned about case folding, punctuation, and white space removal. So I'll ask you to do those things. So using this thing we just loaded in, go ahead and lowercase every, yes. Oh yeah, so start with this. So we've got a tokenized version of the text that we just saw of this sentence. What I want you to do is take in this tokenized list and lowercase it. So it's going to be different than, you know, simply calling lower on the list here. You got to think about how you can go for each of these words and deal with casing. So go ahead and do that. This is maybe a little simpler, so let's give you a minute. Try your skills. Okay, so what did you come up with? Yes. Ooh, Valerie, nice Pythonic for loop there. I like this. Anytime that you use for I and range of length of something, I'm impressed. So let's just demonstrate that. Super interesting. Tokens, I just want to try this out because I think it's cool. Tokens. Not lower. Okay, that seems to have worked. The other thing we could do is what Valerie sent, or Maxime rather, for word and tokens. Oh, she's creating a new one. That's interesting. I'm just going to keep it simple. Tokens 2 append. No, okay, forget it. Let's do her way. Tokens 2. Just okay, so there you have it. Two very different approaches to this question. For word and tokens, and then you can just take each element and append it to a new list. Very nice. Or you could iterate through tokens itself and change each element, and even do something like use an indexer for each placement rather than looping over words. So cool. Nice range of skills here. And Doug sent a list comprehension, which is gorgeous. I must say, use list comprehensions whenever possible. Okay, about less than 10 minutes left, so let's keep going. How do we remove URLs, digits, and hashtags? Great question. So for that, we need to pull out the text from those tweets we were using before. And we're going to try this and see what happens. Oh, that actually worked. Was not expecting that. What happens? What's in here? There you go. Oh, it worked. We didn't call in the column names earlier, so I was not expecting that to work, but it did. All right, so then to remove URLs, there's another regex pattern here. Don't worry about this too much, but it removes URLs. There you go. So there's a single tweet, and then we're going to try to, so here's what a URL looks like, and we're going to try to remove this using this substitution pattern. So look for anything that matches this pattern, replace it with this thing, just blank URL, in the one tweet that we've looked at so far. There we go. That turns into URL, so it doesn't cloud up our analysis. And now we can kind of do it again in a for loop. Another way to do it is with a list comprehension. Again, these are just very nice. And these two things are exactly the same. You can do the same thing with the hashtag pattern. Again, don't worry about the regex, but replace any hashtag with a hashtag, just the word. Any digits with the word digit. And here's what that does. There they are. Okay, and this one's important, so I think we'll take just a minute. There's two ways to count word frequencies. So first off, let's implement the cleaning that we just did. So removing URLs, hashtags, digits, tokenizing. First, you change it into a list so it's easier to work with and see what that looks like. There you go, nice and clean. You can do it with this default from the collections library it's built in, something called counter. That works fine. Another way is with NLTK. And lo and behold, different format, exact same results. And I think, yeah, I'd rather get through this than give you time to code, honestly. So we're just going to do that. I'm sorry you don't have all the time you need to work through these challenges. I think it's really valuable to do that. So if you can take like even 10 minutes afterward to work on some of these, that's great. But I just want to show you how this stuff works, okay? So yes, so tokenize each review. Oh, don't worry about this. There's a solution in that notebook if you want to look at it. Removing stop words. So again, NLTK has a great default here. Let's load into something called stop and see what's in it. And yeah, here you go. Lots of standard words, including pronouns. I think that's generally appropriate. If you were like looking to understand pronoun usage, which is really important for some applications like author identification, you would not remove all this stuff. But in our case, we don't really care that much. And as for stemming, like I kind of said before, here's how you implement stemming anyway. You cut off the end of a word. Grows becomes grow. Running becomes run. Leaves become leave. You can kind of see how this is weird. So leave could mean the word, like I'm leaving, or like leaf. And something that does that a little bit smarter is a lematizer. And here's some examples. Yeah. Well, there's different kinds of stemmers. I almost always use the Porter stemmer. This is a nice default lematizer here with WordNet, and it changes leaves into leaf, which makes sense, right? Singular. POS tagging, another simple application using NLTK. It doesn't work the best, but it's fine for demonstration purposes. If I was doing this at any scale, I'd probably use Spacey, but I'm trying to keep it simple. Oh, it wasn't happy about something. Let's see here. Tokens. Single review. Oh, this is interesting. Oh, because I think of what my review thing looked like above. Let's see here. You know what? That probably doesn't super matter for going forward. Yeah, we're about to change data sets. Don't worry about it. But if you want to know what, sorry. I think just for simplicity, I'm going to go in here, save some time. If you look at POS tagging here, word frequencies, we did that, stop words. Here we go. This is what it should look like. When you do part of speech tagging on something, you just end up with a long list of, these are actually tuples. So they're elements that are tied together. The word I and the part of speech called PRP or preposition, love or verb, I think it's verb present tense or something. But if you want to know what those look like, you can just ask an LTK, or what they mean rather. So hey, what's VBP again? Remind me. And I can find, there it is. Yeah, verb present tense. Okay, there you go. Again, keeping it very simple. And I'm just going to throw a document term matrix at you and I invite you to try these challenges. And we might debrief a little tomorrow, but this is just get you the basics. So to create a document term matrix, we take in our tweet text, we clean it. There you go, looks very nice. We use count vectorizer here and create a sparse document term matrix. This is called sparse compressed format because it doesn't store zeros. So everything in here means that a word occurs in a document. Word at row 0 occurs in document number 266 once. So that's what that means. It's probably a little confusing to understand. So let's put the zeros back in. And just for demonstration purposes, what does that look like? Looks like a bunch of zeros. So this is called compressed sparse format because removing zeros means that you save a lot of memory by not having to store them in anything. There's all these empty placeholders here. But just for demonstration purposes, let's work with the zeros in place. You can get the words themselves using get feature names. And then you can actually create a full data frame incorporating the zeros using this code here. Not super complicated, but don't worry about it. And then we can use this to get frequent words very easily, actually, using one line as compared to with LTK, which took a few. Most common word in this random corpus of reviews, was it, I think? Oh, no, tweets, is the. Not super informative. Anyway, there's a couple more challenges here. There's a lot of stuff we didn't cover and a lot more resources. So this is meant to be a whirlwind tour of NLP preprocessing. And tomorrow we'll work with some application. You'll have some challenges and plenty more time to work through them. So we can all learn from each other in different skill sets. And we're out of time, so I'm going to call it for today. And oh, did I forget to restart the recording? I might have done that.
No, it's restarted. I got it.
Jonathan, that's why you're here. Okay, everybody. Well, as our last awkward moment of Zoom recognition, I'm going to invite everybody to turn on their cameras and just say thanks and goodbye. And I hope to see everyone tomorrow.
Same
There you
time,
are.
same link.
Thank you.
Same time, same
Thank you
link.
very much. This is great. Thank you.
My pleasure. Thanks, everyone.
Thanks so much. It was a whirlwind tour.
So true. See you tomorrow.